My name is Bindu Bhakta, and I'm a natural resources educator for Michigan State University Extension. In this short video, I'm going to be giving a demonstration using a groundwater model to reinforce some of the key points that are presented in the water quantity and the water quality section of the Michigan Water School. During this video, I'm going to give you a brief orientation to the key features of the groundwater model, and also along the way define some key terminology. We'll then be able to review what groundwater is, how it moves, and also demonstrate how groundwater and surface water are connected and how they interact with each other. Finally, we'll be able to discuss that even though we have a lot of water in Michigan, only a very small amount of it is usable. And we'll be able to see that groundwater is a limiting resource in certain parts of our state based on our geology and where groundwater is stored, as well as some water quality issues that may connect to that as well. So briefly, for an orientation of the groundwater model, I will direct you to the front of this model, where we'll be able to see, imagine going out into a vegetated or a grassy area and then cutting right through the soil beneath your feet. Now you'll be able to notice some different layers of sand, gravel, and clay. So these finer, the lighter tan represents finer sand. Down here, you might start to see larger rock materials, so gravel. This layer here is a layer of clay. So you can see different layers and depths. You have a clay layer here, but then you don't have any clay over here. So depending on where you are in Michigan, you'll find different depths and different materials underneath your feet. What we'll be able to see, though, when we get to the demonstration portion of the video, is to use different colors of food coloring so that we will be able to clearly see that within these layers of rock and soil particles, we have a storage of what we call groundwater. So the other couple of things that I wanted to point out are, here are some drinking water wells. You'll notice that they are constructed through different depths. So this one here is a deeper well that's constructed through this bedrock down here, which is a very hard rock material, on top of which is the different layers of sand, gravel, and clay. We can call all of this material that was deposited on top of the bedrock as a glacial drift material, and we'll talk more about that momentarily. So you have this bedrock down here, and we also want to just point your attention to make a connection to the water cycle. So if you imagine over here where my hand is a rain cloud, so water comes down, some of the water hits the land surface, denoted by this green layer here. The water that is able to make its way into the layers of sand, gravel, and clay, when those soil particles are completely saturated by water, what you have now is a storage of groundwater. And so when it filters through those layers of sand, gravel, and clay, completely saturates those particles and rock. And then what we can say is that groundwater keeps moving and moving. So it'll move through these materials. Depending on the type of material, it may move faster or slower. So it keeps moving over time until it's able to discharge into a nearby river, lake, or stream. So we want to pay attention to the surface water and groundwater connection. We also noticed a number of wells that are located here, some vegetated areas. Here is another body of surface water, a lake. And again, we want to notice in the demonstration portion that there are a lot of places under our feet that water is being stored. We just aren't able to see it without the help of those food colors. So just to make sure that we understand what groundwater is, that is when we have rock and soil particles that are completely saturated by water. And so water is stored in the pores space around rock and soil particles and also within fractures. So if you look at this hard bedrock material down here, you can see some cracks and spaces. Those are fractures that develop in this very hard bedrock material. And over time, those fractures now are able to store groundwater. So that water that made its way through these layers of sand, gravel, and clay, and eventually were able to permeate through those fractures and be stored under this area down here. We also want to make sure to note that groundwater moves through different materials or has different permeability depending on what it's moving through. So water travels through gravel pretty quickly, comparing that to clay, where permeability is slower. We also want to consider that certain materials hold on to water. So we can talk about porosity, or that term that defines the capability of soil or rock to hold on to water. So if we look at something like this here, which is a clay layer, that will basically is made up of very small particles and are so tightly bound together that they tend to hold on to water and prevent the downward movement of groundwater. And so we say that that has a very high porosity because it just likes to hold on to that water. We also want to consider where water is stored underground. We want to make sure to go over the term aquifer, and that's simply a geologic media that can store and transmit groundwater for whatever purpose it is intended. So think about that as an underground sponge. So when we think about aquifers, there are a couple different types. Here in Michigan, we have drift aquifers. So I wanted to point your attention to the layers of sand and gravel that are deposited on top of this clay layer here. So this will define an unconfined aquifer up above here, up above this clay layer. And when we have rock and soil particles that are completely surrounded by water, we have groundwater stored in here. And when it's stored within these layers of sand, gravel, and clay in this glacial drift material that was deposited on top of the bedrock, that is what we call a drift aquifer. We also have bedrock aquifers here in Michigan. So if you look at this bedrock aquifer down here, this hard rock material, we have these fractures that have developed over time in the bedrock. And as you remember, water filters down into the soil layers. It completely saturates the rock and soil that's in its path, and it keeps on moving and moving. And over time, groundwater then became stored in these fractures in the bedrock. And that's another type of aquifer down here, is this fractured bedrock that stores a sizable amount of groundwater that can be used for whatever purpose it's intended for. So drift aquifers, where water is stored, groundwater is stored in the layers of sand, gravel, and clay in this drift material. Also in the bedrock aquifer, where water is stored in the bedrock down here. We also want to talk about unconfined aquifers and confined aquifers and what confining layers are. So again, if you point your attention to this area here, so it's this topmost aquifer where you find saturated soil. and therefore groundwater, and it's stored in these different layers up in here. You'll also notice this clay layer again, and then there's an area here that is storing a separated area of groundwater. So it's separated by this clay layer here and the bedrock below. So that's what we call a confined aquifer. And what that means is that this clay layer is putting pressure on top of and down on this geologic unit or this aquifer here. And so what happens potentially is that the pressure allows for the case where if there's a drinking water well that's constructed through that clay layer, there's pressure put on this aquifer here, and you may get a resulting artesian well. So water can move its way through here and naturally flow out of this artesian well here. Another point about this confining layer, oftentimes a good example of that is clay, is that this prevents the downward movement of groundwater. So again, it holds on to water. It may over time eventually allow the groundwater to move through it, but it will definitely slow it down to some degree. So that is just to reinforce the idea of a clay layer and how sometimes if water moves into the layers of sand, gravel, and clay and hits that clay layer, that may keep that groundwater from moving any further down below. So you can now see that groundwater is stored in different units of this model. For the remainder of this video, we're going to be able to see how groundwater is stored below, where it's stored, and how it moves by using a couple different colors of food dye. So the first demonstration we're going to do is where we'll be adding some red food coloring into this bedrock well. So it's a well that's constructed into this bedrock aquifer down here. So it will have the ability to pump water from that structure and pull it up for whatever use that it is intended. So we're going to see how you may not have been able to notice that there was groundwater stored there before, but now this red color, which we'll insert here into this well, we'll be able to see how that moves through the model. And now you can clearly see how groundwater filters into the layers of sand, gravel, and clay, and then it can be stored in this bedrock aquifer down here and move all the way through. So moving slowly over time until it has the ability to discharge here at this river. So now you can clearly see the connection of something that happened at the land surface. If it goes into this aquifer, so it moves into the groundwater, and then it keeps moving and moving until it discharges again. So that groundwater surface water interaction. The next demonstration will be utilizing some green dye. So I'm going to point your attention to this vegetated area here, for example, this lawn area, and we'll be able to see how water moves from the land surface, how it can interact with the geology below, and how it can move into other bodies of surface water. So this water bottle is going to simulate a rainstorm so that you can see two things. One, that some of the water moved directly and ran off directly into that lake. Another thing that happened was that some of that food dye made its way into these layers of sand, gravel, and clay and saturated those soil particles and then kept moving and moving, and some of it discharged directly into that lake there. And so again, illustrating the groundwater surface water connection. Then if you point your attention to this well here, which is across the lake from where that food coloring was located, deposited, you can see how this groundwater under here this well pulls the groundwater that's being stored from some distance away from the well. The last thing that I would like to demonstrate is to see how there is groundwater that is stored in this confined artesian aquifer here. So there's a confining layer of clay on top, and there's a confining layer which we call an aquiclude, which is that top surface of the bedrock. So those two layers confine or allow the groundwater that's being stored in this geologic unit here to be contained within this area. And this aquitar or confining layer is putting pressure down on this area of groundwater, and so it can allow water to flow freely into an artesian well. So we're going to demonstrate that by adding some blue dye here into this well number 6 so that we can put a little color into this confined artesian aquifer and then be able to see how the groundwater moves. You'll notice that that blue dye is contained within this area here. It does not filter into the bedrock because it's being prevented from doing that by this aquiclude or this top surface of the bedrock. You can see how it started over here and it moved quickly to this area over here. And that's also to show you how groundwater moves over time. And then you can also see how that blue color traveled directly into this well. And depending on the amount of pressure, you may have that blue food coloring flowing freely through that well or not. So just wanted to show how this confining layer will keep or separate, I should say, the water that's stored in this unit here, and it'll contain it within that area. So there is no mixing of the water that's stored in that separated aquifer, the unconfined aquifer up here. Notice how the blue color stayed here and did not affect other places of the aquifer. Through this short video, I hope you were able to get a better understanding of what groundwater is, where it's stored, how it moves, and that there is a direct connection between, or interaction between, groundwater and surface water supplies, and that you were able to get a better visual of where groundwater is stored below our feet, that it's able to be stored around rock and soil particles. It can be stored in bedrock. So there are different defined areas underneath our feet that have a sizable amount of groundwater that normally we can't see, but through the use of some food colors allows us to see groundwater, where it's stored and how it moves.